Hello, everyone. This is Dr. Mahmoud Al-Odeh, and we're going to start with chapter 13 for this week. And for this chapter, we're going to talk about the MRP and ERP systems and how we could use these systems to create plans for our demands, to meet our demands. I'd like to go ahead and start with this graph. As you see, this is a graph that will show you the relationship between the different plans, starting with a business plan. When you have a business plan, you will look into the strategies and policies, economic, competitive, and political conditions, and then you create basically a SWOT analysis looking into the strengths, weaknesses, opportunities, and threats. And based on that, you could move on to the aggregate plan. We talked about aggregate plan last chapter, which is basically focusing on the overall demand for our product or services rather than focusing on a specific product. For this chapter, we're going to talk about the master schedule, which is going to focus on a specific product. So we're going to be deeper into the plan from the bigger picture into a more detailed picture. Now, we did talk about the overall objectives and goals and competitive advantages that we have for a business. Now moving into the overall plan, the aggregate plan for the overall demand. And now in this chapter, we're going to talk about the master schedule, or sometimes we refer to it as a master production schedule, where we talk about the individual project. In here in this graph as well, this is a more detail that will show you that even to the customer end, once we have an aggregate plan with our production or service, we consider a family of products, and in the master production schedule or the master schedule, that's going to be the focus for this chapter, and this is going to focus on the individual product. And now also what we're going to talk about material requirement plan, and this will take us to even deeper to the component of each product. And of course, now down here, we will talk about purchasing plans. And on the right side, we will talk about the activity control plans. What kind of activities we need to do in order to control our plans and make sure that we are on the right path. All right, so what is the MRP? The Material Requirement Planning is a computer-based information system that translates master schedule requirements for end items into time-phased requirement for sub-assemblies, components, and raw materials. There are 3 questions for MRP that we will be able to answer these questions by using the MRP. We will be able to answer what is needed, how much is needed, and when we need these materials. Again, it's a computerized information system that we use it in production planning and control. Also can be used for a service as well. We will talk by the end of the chapter, we will talk about how we could use it in the service industry as well. But mainly we need to look into what is needed, what products is needed, how many of these products are needed, and when do we need to offer them and make them available to our customers. All right, let's take a look into the input, the input processing and the output of the MRP. For the input, we use the master schedule from orders and forecasts as an input for the MRP to process it. We will look into design changes such as using the bill of material, and we will look into the inventory records as well to be able to use all these information from forecasting, actual orders, bill of material, inventory record to plan for what is needed, when it's needed, and how we could send these to the customers. As an output, once we put all these together, as an output, we will be able to know the changes for the production schedule. We will be able to know when we have to release orders, and when we have to plan for orders. We will be able to do some exception reports, planning reports, performance control reports, and also we will be able to do some inventory management based on the information that we received. All right, let's go ahead and start with the master schedule. The master schedule, again, it's called also master production schedule. And this is one of the 3 primary inputs in the MRP, states which ends item are to produce, when they are needed, and what quantities. Managers like to plan for enough into the future, so they have responsible estimates for upcoming demands. So why we need to do all of this, why we're using the master schedule, the aggregate planning, and all of these different plans and techniques. We need these in order to meet the demand, in order to help satisfy the customers. The master schedule should cover a period that is at least equivalent to the cumulative lead time, which is the lead time is the sum of lead times that sequential phases of a process require, from ordering of parts or raw materials to completion of the final assembly. So let's take a look into this example that you see. This is the item X. We have 8 weeks demand. What we need here, we need on week 4 100 units, and also we need on week 8 150 units. So now we're going to dig deep in order to create a plan on when we should go ahead and start producing these units to make them available on week 4. Again, this is just a forecasting from previous chapters. When you talk about forecasting, we forecasted, or there's an actual demand of this item X to have 100 units on week 4 and 150 units on week 8. So talking about the cumulative lead time, we have, in this example, we have a product that we need to purchase the raw material in 2 weeks. So as you see, we did not start anything in week 1. We're going to start purchasing the raw material on week 2 and 3. It will take us 2 weeks to buy the material. And then it will take us 3 weeks to do the fabrication, 4, 5, and 6. Week 7 and 8, we will use these weeks for sub-assemblies to do the sub-assembly, which is the component, the smaller component, put them together. And then the last 2 weeks, 9 and 10, would be to assemble all the subcomponents together to make the product available. So the total of 9 weeks of lead time is needed from ordering parts and raw material until final assembly is completed. So now we have to consider also some of the moving time and wait time in additional to the setup and run time. These are the other times that we should consider, not only the processing time. The lead time is considering the move time, the wait time, the setup time, and the run time itself. All right, we did talk about a few inputs and for the MRP, and one of them is bill of materials. One of the techniques, one of the tools that we use in order to know exactly what is needed, the subcomponent of a product, is to use a bill of material. And this is basically a listing of all of the assemblies, sub-assemblies, parts, and raw material needed to produce 1 unit of a product. The bill of materials shows all parts to make 1 item. Each part has 1 and only 1 part number. So you can't find a part number that for 2 products. It's only, each part has only 1 part number. A part is defined by form, fit, and function, and any change requires a new part number. Also, instead of using the bill of material, we could represent the bill of material as a table or as a structure tree. That's another way to represent the bill of material. In the structure tree, a visual demonstration of the requirements in a bill of materials where all components are listed by levels. All right, let's take a look into the example of a bill of material. And you will find that in this table here, that you have the description for this part, which is table, and we have a part number for it to be 100. Now, moving down here into the table, you will find there are 1, 2, 3, 4, 5 components. And these are, to make a table, you need 4 legs, 2 ends, 2 sides, 1 top, and 1 hardware kit. And as you see, we have the part number for each one of these components and the quantity required. So this way we could understand what the component of a table, and we could plan for not just only the table itself, the parent, but also we could plan for the child as well, the legs, the ends, the sides, the top, and the hardware kit based on the demand. All right, let's take a look into the structure tree here. Here's another example of the structure tree where you find a finished chair here. And you will see that that chair will consist of 3 major components. These are the front legs with a crossbar. You will have the seat, you will have the back support, you will have the crossbar, and you will have side rails. So if we need to look into that, we need to identify the quantity for each of these components and subcomponents. So for example here, the chair is divided to leg, seat, and back. The leg assembly, you will have 2 legs and the crossbar. And the seat is only 1 component, which is just the flat wood right there, the seat. And the back assembly will have the side rails, 2 of them, crossbar, 1 of them, and back support, which we have 3 of them. All right, now another way to represent the bill of material is to use the low-level coding. The low-level coding, it will divide the bill of material or the tree structure into level 0, 1, 2, 3, depends on the parents and the child relationship. So these are restricting the bill of materials to that multiple occurrences of component, all coincide with the lowest level at which the component occurs. All right, so now we're done with the bill of material, and hopefully you guys understand what the bill of material is. Now, what I want to do is another input. We're moving into inventory records. Inventory records, we look into the information on the status of each item by period, and we call it the time buckets. And information that we need to look, when we look into the inventory, we look into the gross requirements, and these are the total of a component needed to meet the requirements, not taking any existing inventory into account. Also, we need to look into scheduled receipts, which is basically an open orders released for processing, production, or purchase, scheduled to be received at a defined time, and expected amount on hand, which is basically the current available inventory. Other details that we should look at it is the suppliers, the lead time, the lot size policy, and changes, if there's any changes, or canceled in orders or similar events. All right, let's go back to the assembly time chart, where you find that we need 2 weeks to purchase raw material D, 2 weeks to purchase raw material F, and raw material I, we need 2 weeks. And then moving into the fabrication stage, which will show you also how long it will take you. Again, 2 weeks here for fabrications of part E, 2 weeks of purchasing. Actually, we still have to purchase material C here, and so on. So again, this is just a way to demonstrate the assembly time and how long it will take you in order to meet the demand. And based on this, you could find out what would be the lead time. And again, the lead time is how long it will take you to make one product from buying the raw material all the way to delivering it to the customer. All right, now we've received all the inputs from the bill of material. We looked into the inventory. We looked into the available from the suppliers, lead times, lot policies, and now we're going to process all this together to come up with outputs out of the MRP. The outputs, the primary outputs for the MRP is the planned orders, a schedule indicating the amount and timing of future orders. So this is the planned order. Basically, will show you the future orders, amount and timing, how many, and when these orders needed. The next output is planned order release, which is authorizing the execution of planned order, the amount that should be ordered using the lot size to prevent a negative projected available balance. And the third output would be the planned order receipt, when the order should be available for use, offset by lead time by the planned order release. Changes, these are basically if there's any cancellation of orders or revision of dates or quantities should be also considered as an output of the MRP. All right, we'll take a look into the calculation for each one of these but in just a second. We will finish this first, the output, and then we'll move to an example. Now, what is the secondary output for the MRP? You will have 3 secondary outputs. Performance control report. You will be able to control the process, comparing the plan versus the actual output. For example, we could look into the missed deliveries and the stock outs. We will look into the planning reports, data useful for assessing future material requirements, such as a purchase commitment. Exceptional reports, data on any major exceptions that we should consider, such as late or overdue orders, excessive scrap rate, or requirement for non-existing parents. These are some of the exception report that we will have. Now, for processing the MRP, now, as I mentioned, these are the output, but we need to talk about the calculation. That's what happened in the processing. So we have an input, processing, and output. We know that the input will be from the bill of material and inventory information. And we did look into these information, and we could decide on the output, and we could have an output. So in order to process the MRP, we take all these information from the inputs, we put them together, and we basically create a timed phase plan or time phase requirements for assemblies, parts, and raw material, which offset by the lead time. We should consider the lead time. So for example, if it will take us to assemble a subcomponent within 2 weeks, so we should plan ahead. We should start working on that 2 weeks ahead of time or before that time. All right, now let's move on to the MRP record itself, and let's see how we could do the calculation and read some of these information. So the first, this is what the MRP record looks like. We have a table with the number of weeks or number of periods, and we have 1, 2, 3, 4, 5, and 6 factors that we need to look at. The gross requirement, and these are the total expected demand. And again, you could take it from the forecasting strategies that we've learned, or you could take it from the actual orders from customers. We have scheduled receipts, which is open order scheduled to arrive. So we're expecting these orders to arrive at any minute. And we know exactly in the time for arrival. Projected on hand or projected available. These are expected inventory on hand at the beginning of each time period. Net requirement, that's the actual amount needed in each period. Planned order receipts, these are quantity expected to receive at the beginning of the period offset by the lead time. In planned order release, this is a planned amount to order in each time period. All right, now moving into the development. The MRP is based on the product structure tree diagram. So that's the first thing that we need to use is the bill of material or the tree diagram for a product to find out what is the product and the sub-assemblies for each one of them. And we need to take a look into the quantities that needed from each of these sub-assemblies and how long will take us to put them together. And this is basically what we do to create the schedule. Requirements are determined level by level, beginning with the end item and working down the tree. The timing and quantities of each parent becomes the basis for determining the time and quantities for the child item directly below it. The children items then became as the parent become the parents items for the next level and so on. So that's where when we talk about the levels, the different levels, this is where the parent and the children relationship, you'll start with the bigger component, the bigger product, and then you explode that to find out what would be the subcomponent of each product. And then each subcomponent, also you break it down into subcomponent as well, and so on. So this way you could plan for meeting the customer demands. All right, so here's an example for the MRP. We have a shutter with 2 frames. As you see, we have frames and wood sections. We have 2 frames and 4 sections. All right, now here's the MRP example. That's the master schedule from last week. We have 100 and 150. That's on week 4 and week 8. Now for the shutter, the lead time is 1 week. The frames, we have lead time of 2 weeks, which means in order to finish this and make the shutter available, we need 1 week to work on them. The frames will take us 2 weeks to make them ready. And we have the wood sections, which will take 1 week. So again, the parent is the shutter. The frames, which consist of the frames and the wood section. Again, let's go back to this table here, to this tree. You'll find that's the parent, the shutter, and the children, the frames and the wood sections. We have 2 frames and we have 4 wood sections. And now moving into here, we found the demand or the forecasting to be 100 units on week 4 and 150 in week 50. So that would be the gross requirement for the shutters right there. And we don't have anything in the inventory. So the net requirement would be 100 and 150 on week 4, 100 and 150 on week 8. And then in order to make the 100 available in week 4, what we have to do, we have to plan ahead of time. So we have to start working on it on week 3. So on week 3, we will do the order release, and then we will receive it on week 4. And this way we could make it available to the customer. Same thing for the 150 here. We need the 150 in week 8, and we know that it will take us 1 week to work on that. So we have to start working on it on week 7. However, that's the parent. Now let's move on to the children, which is the frames and the wood sections. All right, so starting with the frames will take us 2 weeks. So if we need 100 shutter times 2, that will give you 200 frames needed. And then when is needed, we have 2 weeks. We don't have anything in the inventory. So that would be the net requirement. In order to make these available, we have to start on week 2. So we could receive it on week 3. So we have to start on week 1. And that will take us week 1, week 2 to be available. So week 3 will be available. So the order release, we release an order, we give an order to the manufacturer saying, okay, well, can you start production on week 1? So we know that we will receive that quantity on week 3. Now for this 150 here that is needed on week 8, we know that because the shutter, the parent, will take us 1 week. So we start on week 7. Now moving into the frames, which is the children, will take us 2 weeks. And we need 2 of these. So 150 times 2, that would be 300 needed by week 7. Nothing in the inventory. So that's where the net requirement is 300. Now, in order to finish this on time, if we need them on week 7, so we have to start on week 5 to work on them because there are 2 weeks as a lead time. All right, now moving into the next child, which is the wood sections. We know that for each shutter, we need 4 of them, 4 sections. So 100 shutters, that equivalent to 400 sections. And when is that needed? Needed on week 3. And we know this is a 1 week lead time. However, we have some schedule receipts. We will receive 70 from somehow from the supplier, from a partner. So we will receive 70 units on week 1, and we're not going to use them until week 3. On week 3, we need a 330 and the 70 to meet the demand of 400. The 330, that would be the net requirement in order to make these available. So we have to ask the manufacturer to work on manufacturing these on week 2. And therefore, these will be available on week 3. Same thing for the 150 that needed in 100 on week 8. We need that on week 7. Therefore, we don't have anything left in the inventory. We have to issue an order, planned order release of 600 to be received on week 7, and that would be the MRP. So you start with a parent, and then you go down. And you plan for the children based on the tree that you have. I'm gonna stop the video right here, and I will see you in another video talking about a different concept. Thank you so much.